Right. So guys, today we're going to discuss about one of the DB in which Python supports by default, that is SQLite3. So import SQLite3. Okay. So when I run, it doesn't throw any error. What does it mean? That means it is available. So this is something that you need to understand. By default, even for Django also, right? SQLite3 is a supported, default supported DB library. Okay. So if you ask me what is the SQLite, it is nothing but the same thing what you do with the MySQL and MS server, but it is a light version. So what you need there in MS SQL is that you need to connect to the user ID, password, and then DB, right? But here that is not needed. Basically, you can directly connect to the DB without worrying about the authentication. No need to give the user ID, password, host, or port. Only thing that you need here is that DB and DB name. This is what the beauty of SQLite. That's why we do call this as a light version of the SQL. Okay, what is SQL? Basically, structured query language. That means I want to communicate to the DB by some sort of structured query. Okay, basically this also follows RDBMS concept, relational database management concept, and it is indeed a structured one. So let me put certain aspect to it. It also follows RDBMS. It also structured. It is open source. It is same table and field concept. It supports all primitive data type that is supported by SQL in general. Okay, it is light version of MS SQL. DB is enough to connect. It doesn't run as service. It runs as application. Okay, you would have noticed, right? MongoDB and SQL are something that runs in our local host generally, that runs as a service, but the SQLite doesn't run as a service. It's an application wherever, whenever you want to use, you can use, and you can connect to the DB. Okay, these are the few things that you need to keep in mind when you want to learn SQLite3. Okay, so why we're inducting or why we're introducing the SQLite3 as a part of a Python is that when you learn the SQLite3, you will be ultimately learning the PostgreSQL, you will be ultimately learning the MySQL and MS Server, because all those connectivity and all those execution part remain same. The only difference with respect to SQLite and other structured DB is that the way we do the connection. Here you will be connecting only with the DB, whereas in those DB you need to connect with their user ID, password, and the server. Okay, that's the only difference. Rest of the case, the way we run the code, the way we execute the code, what are the different structure, everything remain the same. So that's why it is always good to know the basic version. And importantly, since it is indeed supported by Python in a default way, it's good that we learn this as well. Okay, now we'll directly heads up into a code structure. Okay, so let me just put it here so the better viewing. Okay, so what is the first thing? Establishing a connection. So connection is an object which is going to connect using this one. So here, whatever that you see after the equal is something that default one. SQLite3 is an imported library and connect is a function of your SQLite3. So now, as I told, you need to give only the DB name, networks.db. Okay. So if you connect this, it will directly connect to the networks DB. That is sufficient. Now there are two questions. What if I don't have that particular DB earlier, and where it will go and try connect? Because I never given any path. If it is a my server, if it is a MySQL, if it is a Postgre, if it is a Mongo, you can connect to the server where the code is running. Most basically the local host 127.0.1 and with a different port, because in MS SQL we'll be giving the port and as well as the server, which is indeed a local host by default, right? So it can directly go to that particular localhost and it can connect. But here we don't have any such server for running this. So if I give this as it is, right, obviously it will go and check your current folder. It will go and check your current folder whether the DB exists or not. If the DB exists, it will connect to the DB. If the DB doesn't exist, if the DB doesn't exist, it doesn't worry or it doesn't throw error. Instead, it will create the DB. Okay, so let me showcase you the folder that I have as a part of this program. Okay, look at that. This is the folder that I'm running my current file, and you can see there is no such DB file. Now let me run these 2 lines of code. And if I open this, there you see a networks DB, a DB file got created, and that is of 0 KB. That is of 0 KB because it's just a DB, doesn't have any table field, so and so. Okay, so this is what the first thing that you need to keep in mind, right? It doesn't worry about the localhost, it worries about the folder structure. If you just give the DB as it is without mentioning any folder, it will go and check the current folder in which your Python is running. So look at that, C drive user 91897 desktop, this date, and Python underscore SQLite3. Since this is running in this folder, right, it will try to connect on the folder. If you give the folder structure like this, C drive, desktop, something like that, it will go and check that folder. So it's up to you. Either you can specify a normal one, or if you want to specify a exact kind of structure, you can specify that. That's the 2 things. So here, if the DB is not there, it doesn't worry, it will create a DB. Fine. What is the next thing that you need to do? It execution of a query. Okay, so let us start with this basic CRUD commands. What is CRUD? CRUD. Create, read, which is nothing but a select command, update, comma, delete. So these are the basic commands that everybody needs to understand. So here what I'll be doing is that I'll be teaching you 3 commands for the execution of this SQLite3 because our focus is mainly on the SQL and Python part. In fact, Python part than the SQL part, because the query is going to remain the same. Whatever that you associate or whatever that you do with MySQL and MS Server, the same command value you're going to execute here. So I'm going to play a major part in a Python than that of SQL. Okay, so this is the basic command. And in general, queries are broadly categorized into DML, data manipulation language, and DDL. If you have any role to play, that is what we call it as manipulation. If you don't have any role to play in a DB, then that is called data descriptive, like select statement, alter kind of stuff. DML means you're gonna take the data and you're gonna manipulate. So if your involvement is needed, that is manipulation language, and if your involvement is not needed, that is a descriptive language. That category precisely, your command belongs to that special category. Okay. Now, what is the next thing that you're supposed to do? I have already showed you that our DB is very empty as of now. So let us create a table here. So query is equal to, always give the triple quotes whenever you write a queries inside a Python, because there are cases where you may add some single quotes or double quotes in between some data within a query. And sometimes what happens if you start with a double quote and inside your string, if it has some other quotes, right, double quotes, it might end up in a mess. So better to keep it very simple. Write a query inside the triple quotes. Okay. So now I'm going to create a table. As you know, it is not a case sensitive, but still the commands need to be in the form of capital letter. Create table and then table name. So let me create sports, and then followed by the column. Say name of the sports, and the type is text. It is similar to what you associate with the varchar in SQL, variable character. Similarly, text, and then something, year of invention, which is integer, and then you close it up. Now look at that, name and year of invention, YOI, is enclosed with the double quotes, right? Now imagine if we had a double quote at the start, it might have the confusion whether to read the complete query or in a bits and pieces, right? So just to avoid this only, I am starting this with the triple quotes. Now, what is the next thing? I have a query. I have a DB that's supposed to be get connected. Next thing is that very straightforward, the execution. Okay. So now any name followed by what you are supposed to do, that connection dot execute. What you're going to execute? You're going to execute the query that you basically created at line number 50. Okay. Then what is very important? Connection dot commit and connection dot close. And everybody knows is commit is a kind of a command that is needed for our data insertion only, just to make the transaction fulfilled. Okay. So commit is mainly used for insert operation, but still on a precaution, you can keep it as a base for all the commands. So commit and close is very, very essential as part of any DB process, because if you don't commit the transaction when you try to insert, or rather if you don't close the connection part that you opened initially for the DB transaction, then your DB is prone to so many malfunctions. Imagine DB plays critical role in any project that you see in real world, not only in a specific project. I can say any project, whatever project that you yourself associate, right? This DB will play very, very, very critical role. So you need to be very careful of the close command. So when I run this, you cannot see the output here because you're trying to do or you're trying to connect to the DBs. So you cannot see the output here. Okay. So now what you can do is that go and see the folder. Now you can see it says 8 KB of data is produced. 8 KB of data is produced. That means what? Something is added here. Okay. Similarly, what you can do the insertion part as well. Okay. Look at that. Let me create another query. Query is equal to same triple quotes and then insert into sports for these columns with the values of some dummy values. That's it. This is the basic query even in MySQL. Okay. So this is how the queries need to be executed. So when I run, by this time it should have been done with the insertion. Okay. So now if I go look at that, it's 8 KB of data, but I'm pretty much sure that insert would have happened. Right. Now this is the basic commands. Now your Python code will have a little deviation when it comes to the select statement. What you do with the select statement? Same thing. Okay. Query is equal to select star from sports. So what happened? It will retrieve the data. It will try to get the data from the DB. So now output needs to be displayed in a Python shell. So what you have to do? You need to do some sort of print statement. What print? You need to print this execution with this function, which is going to help us in getting all the data. Okay. There are a lot of commands that you can yourself associate, but fetch all is one command where it will fetch all data from the selected table. So when I run, look at that. The data that I inserted in my previous execution at line number 16 is getting displayed. So what usually happens with the output of the select is that it will display the list with each rows will be associated, or each row will be displayed in the form of tuple. If you have two data, it will be like list which contains two tuple of rows. That's how the output of select statement usually displays. Okay, so it will be like tuple of list. If you have 10 rows, it will create a 10 tuple inside of one list. This is how their select statement parts. Okay, if you look at line number 12 to 23, nothing I did a change. The only change that I did was my queries 15, 16 and 17. That's the beauty of Python. The code that you're going to use for execution of queries is very less. Only thing that you're supposed to do was change of queries. Whenever, wherever you need, you're going to do the structured query changes, whether it is insert, delete or alter, update or whatever it is. Only changes that you're going to do is that either you can comment this and you can write the another command. Either it is alter command, either it is a drop command, either it is a delete command. So that's what I told. I'm not going to dig deep into the concept of the query execution. Rather, I'll be focusing towards the way you need to execute this Python code perfectly, because there is a loopholes here and there which I'm going to rectify it right now. But on the whole, this is how the code get executed. Okay, but what I did right now is that I just showed you that a DB file created, a data is created, but you need to see how this DB file works, how the DB file exists, right? If it is a server, you can directly open your the corresponding tool, either a workbench or some other server, to see the data on a corresponding table. But this something work as an application, as I told. So you will be getting this DB file. You need to download some other tool to see the DB. Okay. So for that, let us go to the browser. So hit this website, DB browser for SQLite, and click on downloads. Okay. So either you can download the installer or you can keep the non-installer. Installer means it will be available in your system always. No installer means you can open that on a need only, on a demand. So let me click this. Okay. So let that get downloaded for some time. It's hardly 18-19 MB of data, so it won't take too much of a time. It is downloading. You can see this is the and this is not the one and only tool that you have. There are a lot of tools, but something which I feel very user friendly is this specific tool, and it has a basic feature only. So being a beginner, right, it's always good to learn the basic stuff. That's what I was choosing this DB browser tool for, seeing the DB file that is created during your SQLite execution. Okay, so it is indeed executed. Let me go to that folder, cut that, and paste it in the same folder where you are using your DB file. You can keep it anywhere because you're going to open it right away. Okay, right click and click extract all, because usually that comes with a zip file. Okay, so you cannot open the zip file. Make sure that you extract that at any folder that you wish to have. I'm keeping it in my same folder. So open that and scroll down to see an icon of SQL. Look at that DB browser. Just open this. Just open this. It will open this specific tool. Let me repeat it again from the base. Once you're done with the download, it will be in a zipped format. So right click and extract. When you extract, it will show this folder. If you extract directly, it will show in this folder. If you extract in some other folder, go to the folder, open that again, and scroll down to see an icon of this DB browser for SQLite. Double click it will open this tool. Now what you have to do is that you connect your DB, open database, and I know that my DB is in this folder, right? That's it. There you see, the moment I got connected, it is displaying that the table 1 is created and table name is sports, and it gives the schema. Schema is nothing but the template of in which you created the table. This was the template. And if you want to see this in a detailed pictorial representation, right click and click on the modify. You can see that I've created two names and the type of it. You know that these are the constraint. Okay, so when you see the SQL, you can see this in a detail. Constraint, not null constraint, primary key constraint, auto increment constraint, unique constraint, default constraint, and check constraint. If needed, you can add this. These are added as a part of your create table concept, create table queries. Okay, as of now, we don't involve too much of constraint. Basically, I just added a normal name to it, just a name and the field. That's it. Okay, now this is how the table will look like, and if you have created a number of table, all will be displayed here. And now to see the data that you added, click on the browse data column and you can see the data that is getting displayed here. So this is how you need to open your DB file and see the data. And if you want to run your query, you can run somewhere here. Look at that. Whatever the query, that same thing. Insert into Look at sports, name, comma, year of increment, values, football, 1880, and you select and run. It got executed. When you click on browse data, look at that. The same thing got executed. That's what usually happens, right? Either you can run in a tool directly or you can run via your Python. Now, let me run this Python code. It should display two outputs here. It should display two outputs here. Okay. But unfortunately, it is displaying only one output. Look at that. By this time, you should have displayed the sport. Correct? Sports called football. But it is not displaying. Why? Because the transaction that you executed is still open. How I'm saying? Because I've added this football and I can see on the screen, but unfortunately, I'm not committing it yet. So this commit on a tool should happen via this one. Click on the write changes. So write changes means you're done with the commit. Now you go and run your query. Now the football is coming. Now by this time you would have understood how important is to do the commit. If you don't do the commit, either when you execute in the tool or you execute via your Python or some other software language, the transaction will be blocked. Next output will not be coming, or the next transaction will not happen. So commit and close are two essential part of any DB. Okay, of course, commit is for insert operation, but still you can keep commit in general. So these are the ways in which you can work with SQLite operation. Okay, these are the ways in which you can work with SQLite. Okay, after this, what I'm going to show is that how better code this can be modified upon, because what you're doing, you are setting up a default folder for the DB. But I'm going to introduce a certain concept where the system itself will ask you to select a folder. So I'm going to make these things in a better user friendly. Okay, that by introducing a concept of tick inter.